We're going to look at the law of cosines for a non-right triangle. So again, if we have a triangle, and we usually label these corners with A, B, and C, capital letters, and then across from them. So across from angle A is side A, across from side angle B is side B, across from C is side C. So the structure of this law of cosines is that we have these opposite pairs, like this side A and this angle A over here. If you notice in each one of these, and really we only need one of these law of cosines equations, is that it only uses one angle. That one angle that we have here is right over here. And then the side across from that is only written right here. So we see that in each of these cases. So if we really remember that these are opposite pairs, this will help us with this law of cosines, and we could just have one of these and we can use them for anything. We also notice that there's two other sides. So this B is in here twice and the C is in here twice. So if I look at the other ones too, like this A is twice in here, this C is twice in here, and so on with these other ones. So we see them double. So it'd be really hard actually to solve for those if we see it twice in an equation, especially when one's squared, one's not. Like that can be really challenging to be able to find out what that is. So what we're going to be solving for is like what I have highlighted in the first one. Either that side that stands alone, all squared, so like A squared, or that angle. So those are the two things that we're going to be able to solve for in this law of cosines. So once again, this is for a triangle that is not right. You could use it for the right triangle, but you probably really want to use your SOHCAHTOA with that. It's going to be much simpler. And this is if you do not know an angle side pair. So those opposite pairs, there's one we know and one we don't know. So there's going to be a couple cases we can use this. We can use this in cases where we know all three sides, and then in cases where we know one angle, but we know the angle in between two sides. So we don't know the side across from the angle. So we're going to look at both of these cases and how we can solve them. Okay. Now there is one little caveat here, though, with the law of cosines that can help us out, and actually it really ties in with our law of sines too, is that we could only have one, of course, we can only have one angle in the triangle that has an angle that's more than 90 degrees. If all the angles are going to add up to 180, only one can be more than 90 degrees. In our law of sines, we have, let's look at this, actually, this example here of this sine here. So if I do sine of 30 degrees, okay, I get 1/2 for this. Okay. So if I do the inverse sine of 1/2, it gives me 30 as a result. Okay. When I have the sine of 150, put in my calculator, I get 0.5, so 1/2. But when I do the inverse sine of 1/2, I still always get 30 degrees. I'm not getting that 150 degrees. I would have to know something more about this, knowing that there's actually two different values. Actually, there's many different values, different angle values that would give us this value of for sine being 1/2. The calculator is just going to give you one answer. Okay. So now for cosine, if we do inverse, we can get answers that are in between 0 degrees up to 180. So inverse sine will not give an obtuse angle measure. So this is it will not give something that's more than 90 degrees. This does not do that. So we're going to use inverse sine to find acute angles. So really the smallest ones in a triangle. But we can use inverse sine to find obtuse, so large angles in a triangle. Okay. So even if I tried something like the inverse cosine of 1/2, I get 60 degrees. And actually to get something that's larger, it's going to be a negative. So if I did an inverse cosine of negative 1/2, I get 120 degrees. So I can get angles that are higher than that. Okay. So that's going to be one big lesson, and that's also in this note, and we're going to see that play out into this. So just giving you a little heads up. All right, so let's look at one triangle. So if you flip in your note guide with me, we'll definitely want to write some notes. I'm going to try to use some colors here to be able to organize this information here for you as well. So now we could label this A, B, and C. We could not too. We see we have 3 sides to this, okay? And we could really find any angle that we wanted to with our law of cosines, but what we're going to do is we're going to find the largest angle with our law of cosines, because then that's going to help us and we can use our law of sines to find those other small angles and we won't have any issues. So if I look at my largest side, that is this side, so this is going to be my largest angle. I'm just going to call that A right now. Okay. So we're going to be looking for that angle. So I'm going to work with this law of cosines. I'm going to end though with this cosine of A. So looking at this law of cosines here, I'm really focusing on this, and so I just wrote this end part. And then let's write the other parts. So the way that this makes sense then is that if we look at the side across from that 41, I'm going to have 41 squared over here. Now I'm going to use the other 2 sides, and it doesn't matter which order. So that formula, it says that we're going to have each of these squared and added together, and then minus 2 times each of these values. So that's where that, the formula said A squared equals B squared plus C squared, which kind of looks like the Pythagorean theorem, similar, but we don't have a right triangle, minus 2 times B times C times the cosine of A. Okay, now this one's probably the hardest one to be able to solve, so we want to have some really good notes about this. So our goal is to get this angle A by itself. So again, with order of operations, we're undoing things, but first let's see what we can simplify. So some things that we can do is we can find out those different square values. So we can find out 41 squared. We can find out 30 squared. We can find out 22 squared. And then we can also multiply these values together. So the 2 times 30 times 22. So we're subtracting 1,320 times the cosine of A. Then we're going to see if we can simplify anything. And the one thing we can simplify is we can join these 2 together and we can add them. We cannot join that with that 1320 because that is being multiplied with cosine A. So we cannot join that one together, but this other part we can. And so when we do that, we still have the 1681 equals 1384 minus 1320 times the cosine of A. Now this is like if I had 5 minus 8x, I know I can't combine those together. And this is like that because this cosine A is an unknown. And if I don't know what I'm multiplying 1320 with, I can't then combine those numbers in front because they're not like terms. So now here starts my process of undoing. So PEMDAS, I'm undoing this, so I'm looking to see any addition or subtraction to undo. So I'm gonna have to subtract this 1384 from both sides. So we get 297 equals a negative 1320 cosine A. All right, then from here, I'm going to have to look at any multiplication or division to undo. Sure enough, I'm going to have to divide by negative 1320. Okay, now when I put this in my calculator, I am going to get a decimal here. Now this one actually decimal stops, right? Sometimes they run on. So I get negative 0.225. And this will equal cosine of A. Now I expect a decimal here that's in between -1 and 1. If you have something outside of that, you're not going to find an answer for this. And you might have some work that's incorrect above, or maybe this really didn't form an angle with those side dimensions. So we're going to do an inverse cosine, and really we want to practice by using that answer that you have in your calculator, especially if that decimal runs on, because we want to have the most accurate answers here. So in my calculator, when I do that inverse cosine, I get 103.0 when I round it. And this is an angle, so degrees. So if you have a negative decimal, you'll get an angle that's more than 90 degrees. If the decimal is positive, it'll be less than 90 degrees. We did know that this was the largest angle, so it was the only one that was even possible to be over 90 degrees. So I'm just going to fill that in over here, so 103 degrees. Now once we have that, if we want to find the other angles, we can use law of sines now, because we have this opposite side angle pair. And that probably is going to be more efficient to do, because this was a lot of work to be able to solve with a law of cosines. So once we get that initial one, we can find other values. So I'm just going to set up another one here. So law of sines, and that's an easy one to remember. So sine of 103 degrees over its opposite side of 41. And then we can decide which angle to find. I'm going to go for this angle up here. I'm going to call it B. Okay, so I have sine of B over 22. So to solve this, I'm going to multiply both sides by 22. Then I can put that in my calculator. 22 times the sine of 103 divided by 41. I get this nice decimal here, which I anticipate of having something like that. Now this keeps going. I anticipate a decimal because this is what sine of B equals. It's not my angle yet, and sine always equals a value in between -1 and 1. So I'm going to do an inverse sine of the answer. To find B. So don't just type in that decimal value. We want to round at the very end, not in the middle of our work here. And I get 31 point, and if I round, I have a 5-2, so it stays as a 5 if I'm doing the nearest tenth. So I'm going to label that over here on my triangle, 31.5 degrees. I have one more angle to find, and I can look at all of them adding up to 180. If I wanted to use the law of cosines, I could. If I wanted to use the law of sines, I could. And so when I take them and add them up and subtract that from 180, I get 45.5 degrees. Now we could have found that 45.5 degrees before we find the 31.5 degrees. Either one would be fine, whichever order. But remember, we use that law of cosines to find that big angle. If we wouldn't have done that, if we would have found one of those smaller angles, then we'd have to be really careful what we're using our law of sines for. So it's best to find that big angle right away with the law of cosines, and then you'll be safe. Okay, we're going to look at one more example here. And this is actually the easier example here. It was a little bit more work when we had to find out the angle. So again, in this one, this opposite side pair, we don't know that. This is what we're looking for right away. Okay, so one of those we have to find, and we don't know it. So I have this angle. I always write that angle in right away, so I'm going to write cosine of 58 degrees here. Then on the other side of the equation, I have that side opposite. And right now we're just calling this x, so x squared. Then I'm using the other two sides. So 12 squared plus 15 squared. You could have a different order for those. And then my formula says minus 2 times the same two sides. So 12 and 15. So from this one, this was a little bit easier because we have numbers all on this right side. So I can put that whole line into my calculator. So I'm going to do that. I encourage you to do that as well. So my calculator gives me an answer of 178.229. And I'm not rounding it yet because I'm not done with the problem. So now from here, we're going to square root both sides. So I'm just going to square root that answer. So I'm going to do a square root of the answer. And now I can round. So I have 13.35, so that makes this a 13.4. So now from here, we're going to use our law of sines to find the other sides. We could also use our law of cosines. This is where we want to be a little bit cautious here because we're going to be using two sides and an angle that's not in between them. So if I look at which side is going to be which angle is going to be largest, this one here is our largest angle. So we're going to avoid that with the law of sines. And so instead, we're going to find this angle right here. I'm just going to call it angle A right now. And you could have labeled everything with A, B, and C at the very beginning. But I want you to think more of how those sides and angles relate to each other. So we're looking for angle A. So sine of angle A and the side across from that is 12. And then the angle pair we know is at 58 degrees, so sine of 58 degrees over its opposite side of 13.4. 13.4 is a rounded number, so there is a little bit of error in finding this angle A, but we'll be close enough in here. Okay, and then we're just going to proceed with solving for this. So again, we're going to multiply. I see that A there, so I want to get rid of that denominator. I'm going to multiply both sides by 12. So I have sine of A equals this. Actually, I could put this all in my calculator and find that decimal. I'm going to do that. And I would encourage you to check these numbers too to make sure that you're getting that. Sometimes we're not using our calculators appropriately, but if we never check, we don't know. So 0.75944 and so on. So we're going to do an inverse. So angle A is going to be from the inverse sine of that answer. (49.41), so 49.4 degrees. So for that last angle, let's take 180 and let's take off these other two angles. And we get 72.6 degrees. So that angle is less than 90 degrees, so we would have been safe to find that with the law of sines. We just didn't know if it was going to be less. There's a possibility that that one could be one that's more than 90 degrees, and an inverse sine would not find that angle then, if it was. Okay. So these do take work for them, and so we're looking for quality, not necessarily quantity. So we want really good work on a few problems so we get this cemented in. And I really want you to look at how these different sides relate to each other, and not just like, it's not memorizing A, B, C, and where they go and stuff. It's more about how they relate to each other with those opposite pairs.